Alright, so now I'm going to show you another way to solve this problem. Okay, we still have 4 couples at a party, and 4 of 8 people are selected to win a prize. No person can win more than one prize, and we're asked to find the probability that at least one couple wins a prize. Okay, so what I thought, I did in the previous video, I did it by complementary counting, and that seemed pretty straightforward. But I thought counting directly sounded pretty straightforward too, because it's really only 2 cases. Either, let me list those out. So we have, actually let me draw a line across here. Alright, so we only have 2 cases. You can either, I didn't mean to put it. So case 1, you would have exactly one couple. Exactly one couple, and then you'd have 2 other people, and those other people would be from different couples. Okay. Alright, so you would have, in this case, you'd have 8 choices for the first person, because it doesn't really matter what couple they come from. And then you eliminated one couple, so you'd have 6 people left. Okay, and then you maybe eliminate that couple, the next couple, so you have 2 couples left, so you have 4 people. And now you have 3 couples, and then you want exactly one couple to win a prize. So you would choose one of the 3 partners of these couples you've already chosen to win the prize. So I thought, well, then there's 3 ways to choose the person who wins the 4th prize. That seemed fairly sound at the time. And then the other case that I thought was, is just where you have exactly 2 couples. Exactly 2 couples. Okay, so so you'd have 8 choices for the first person, and then you would have 6 choices for the second person, and now you want the other 2 people to come from one of these 2 couples that you've already chosen. So you have 2 choices for the third person, and then finally there's only one person left that goes with the couples that we've already chosen, and so you'd have one person left. And so I added those up, and I got what would this be? 8 times 6 times 4 times 3 plus 8 times 6 times 2 times 1 over, because we're calculating probability, and remember our total number of outcomes was 8 times 7 times 6 times 5. And this is assuming that order matters. Okay, so let me simplify that a little bit. I can factor out an 8 times 6, and then I've got 12 plus 2 over, and I got 8 times 6, and then times 7 times 5, right? Just rearranging the denominator there. And I can cancel the 8 times 6, and I ended up with 14 over 35, which was not the right answer. Okay, so this is not the right answer. And I thought, what am I doing wrong? Why isn't that right? What am I missing? I'm missing some possibilities here. So the next thing I tried was, I thought, well, let's add them all up, because I know that the total, if I add up all the different ways, I've got case 1 and case 2, and then I had my original case up here, which was the complement of what I actually wanted. If I add up the complement plus the cases that I do want, it should all add up to this 8 times 6 times 7 times 5, right? Or 8 times 7 times 6 times 5. So I thought, well, okay. So the complement was 8 times 6 times 4 times 2. That's the number of ways that we can choose the winners from 4 different couples. All right. And then exactly one couple plus 2 other people I had calculated as 8 times 6 times 4 times 3, and then we had 8 times 6 times 2 times 1, as that's what I had as the number of ways where you could choose exactly 2 couples. And that should have been equal to 8 times 7 times 6 times 5. So I factored out the 8 times 6, And and I ended up with an 8 plus a 12 plus a 2, which is equal to 8 times 6 times 22, which is not equal to 8 times 6 times 35, right? Because the 7 times 5 is 35. So, okay, I'm missing something, and I was pretty confident about this complement. And whenever you run into a problem with probability, it usually has to do with being consistent as far as how you treat order in the numerator and the denominator. And in the denominator, the simplest way to count the number of ways that the prizes can be distributed is just 8 times 7 times 6 times 5, which assumes that all these prizes are different and that the order matters. Okay, so it makes a difference whether Jane wins the big screen TV and Pamela wins the toaster, or whether Jane wins the toaster and Pamela wins the big screen TV. Okay, so I'm assuming order matters, and I have to be consistent between my numerator and denominator. So, so what's wrong with the way I did this? So here's what I finally figured out. This 8 times 6 times 4 times 3 up here, this assumes that you've chosen one person from 3 different couples first, and then you choose the second person from one of these 3 couples last. Okay, so it's chosen after the other people. But the other person from the couple, so you have exactly one couple. That other person from the couple could have been chosen second, or it could have been chosen third. But I assumed here it was only chosen fourth. They were only chosen fourth. Okay, so we need to revise our method of counting here. So I'm going to redo case 1 because I have to make sure that I take into account that the person from the couple, the second person, the partner person from the couple, I have to make sure that I count the other ways that the other orders they could be chosen in. So what I did is I said, okay, let's let A be the person from the first couple that's chosen. Okay, so let's say that the second that couple A is also the one that wins. The two people win the prize. Okay, so we could choose 2 people from one couple, and then we could choose B and C from different couples. Okay, or we could choose A, and then we could choose B, and then the winner of the third prize could be from couple A, and then we could have C. Okay, or we could have A, B, C, and A. Okay, so that's where the last person to win a prize came from the couple that was chosen first. Okay. All right. So again, I'm just assuming the A is the first is the couple from which the first person who wins the prize is from. Okay. So other orders, I could have the second person. So let's say B is the second the second couple that wins a prize. Okay, so it's the first person from the second couple that wins a prize. Okay, and then the next person could be another person from the couple B, and then we could have C. Or we could have the case where we have A, B, C, and then the last person comes from couple B. Okay, or we can have A, B, C, and then maybe the last person comes from couple C. Okay, so we actually have 6 different ways, the orders that these could come in. So let's calculate the for just one of these. So we had 8 choices for the first, and then the second person comes from the same couple that the first person came from. So we have 1 choice there, and then we have 6, and then we have 4. In this case, we have 8 choices for the first, 6 choices for the second. The third person in this case is comes from the first couple, so we had 1 choice there, and then we had 4. So all of these are really 8 times 6 times 1 times 4 in some order. So this is 8 times 6 times 4 times 1. This one is 8 times 6 times 1 times 4, okay? Because you see, once we've chosen, we're assuming that the middle 2 prizes went to the same couple, okay? So this one is 8 times 6 times 4 times 1, and this is 8 times 6 times 4 times 1. So we end up with really 8 times 6 times 4 times 6 instead of what I had before, which was 3, because I had forgotten the cases where the second person from the couple wins the prize either in the second place or the third place. Okay, so hopefully that made sense. And then for case 2, okay, we could have A win the first prize, and then the second couple or the second person to win the prize is also from A, and then the last 2 people are from the B couple. We could have A, B, A, B. We could have A, B, B, A. So we actually have 3 ways, and this is going to be 8 times 1 times 6 times 1. All these are going to be 8 times 6 times 1 times 1, and this is 8 times 6 times 1 times 1. But there's actually 3 of them, so we have 8 times 6 times 3. Okay? So now if I add those all up, like I did before, add up all my cases, I have 8 times 6 times 4 times 2. That's the complement of what we want. 8 times 6 times 4 times 6, and 8 times 6 times 3. And if I factor out the 8 times 6, I've got 8 plus 24 plus 3. Okay, and that actually is 8 times 6 times 35, which is equal to 8 times 7 times 6 times 5, which is the total that I wanted. Alright, so I'm starting to run out of time. I'll finish this up quick. So what I want to do, if I count this directly, it's 8 times 6 times 4 times 6. That's 8 times 6 plus 8 times 6 times 3 over 8 times 7 times 6 times 5. Okay, so we can cancel out the 8 times 6 throughout, and we end up with 24 plus 3, which is 27, over 35. Okay, so that matches the answer that we got before, and that's the correct answer. And it just goes to show that if you get a problem wrong, don't get discouraged. You can actually learn something from it, and it also points out how critical it is to get the right to be really consistent in how you consider order in the numerator and denominator of your probability. So, because that's where I went wrong, is I was messing up my order. I wasn't counting all the possible orders of the way that people could win prizes. Okay, so so there you go. I hope that you learned something from this too.